I received a request for help with this question, which is 8.2, number 11. If you look in the top right corner, if you're in either the study plan or the homework set. So I'm going to click on View an Example here. And it says, suppose a simple random sample of size n equals 75 is obtained from a population whose size is capital N equals 15,000, and whose population proportion with a specified characteristic is p equals 0.7. So first thing they want us to do is describe the distribution of p hat. So I have kind of typed this up over here. So the thing that they want to know when they say describe the distribution is they want to know the shape, the center, and the spread. Now the shape is normally distributed, but we have to show why. So first of all, it was a simple random sample. That's the first requirement. Then we need to prove that n times p times 1 minus p is greater than 10. So where am I getting that from? Let me pull up the notes real quick for chapter 8. This is particularly section 8.2, so I'm going to go to the central limit theorem for proportions. If I can get my computer screen to scroll through it. There we go, right there. So it has to be a random sample. Great. Then I have to show n times p times 1 minus p is greater than 10. So that's what I'm trying to do right now. So n times p is 75 times p, which is 0.7, times 1 minus 0.7. So I'm going to grab the calculator. 75 times 0.7 times 1 minus 0.7 would be 15.75. So that's where I got the 15.75 from. That is bigger than 10, so yay. That means that it's normal. And then I have to do this to prove that it's independent. I need to know that little n, which is my sample size, which was 75, is less than 5% of the population size. The population size in this case is 15,000. So 0.05 times 15,000 is 750. And 75 is certainly less than 750. So yes, I have that condition met as well. That means all three conditions are met, and that's what makes this normally distributed. Now, to be honest with you, when we're working on exams and stuff, a lot of times we'll skip number 1 and number 3 and really go with number 2 because we kind of assume number 1 and number 3 are taking place a lot. So on an exam, usually it's just testing that middle one in the center. All right, now we want to know the center and the spread. Now the center, according to the central limit theorem, shape, center, spread, so we said normal distribution, the center is the mean, which is p, your population proportion, which in our case was 0.7. So there's the mean, which is 0.7. Then the spread is your standard error. So we're going to have to calculate that. The formula for it comes right from the notes. It's the standard error of p hat, which is sigma p hat, which is the square root of p times 1 minus p over n. So I need 0.7 times 1 minus 0.7 over n, which was 750. Now there's a couple ways you can do this. You can just do square root 0.7 parentheses 1 minus 0.7, close your parentheses, divided by 750. That works. Or if you can do it in your head, 0.7 times 0.3, because 1 minus 0.7 is 0.3. There's another one. Or if you like it to look just like it does on the page, you can actually use the alpha F1 button, pick number 1. It'll make a numerator times over a denominator, and I can make it look exactly like it looks on the page. If I like, I can even use the parentheses in there and make it look exactly like it looks on the page. So let me put parentheses 1 minus 0.7, close parentheses, enter. So lots of different ways to get it, but it's 0.01673. So let me type that up. Oh, except I'm an idiot. It's not 750. It's 75. 75. Clear. Hold on. Let me do that again. So alpha F1, number 1. Sorry, I did that wrong. I pressed the wrong button. Alpha F1, number 1. There we go. 0.7 times 0.3 over 75. Not 750. 75. 0.0529. There we go. So 75. My fault. So it's 0.05. Oh goodness, I lost how many decimal places that was. 2915. 0.052915. You're going to want to keep about 6 decimal places with this, so I'll make a note of that. So note, keep 6 decimal places for this standard error. Let me type that up, for standard error. Otherwise, it will not be accurate enough and you'll be in trouble. So make sure you keep 6 decimal places. And again, make sure you use 75, not 750, 75, because that was the sample size. Sorry about that. Okay, so now we need to find the probability that the proportion p hat is greater than, oops, I clicked off the example there. All right, so we need the probability the proportion p hat is greater than 72.72. All right, so the probability of obtaining x equals 54. So just a real quick note, let me remind you of 54 getting you the 0.72 real quickly. So just little note, p hat is x over n. So p hat equals x over n, which was 54 over 75. Okay, so 54 divided by 75 is 0.72. And so that's where the 0.72 came from. So if they had said x is greater than 54, that's the same thing as p hat is greater than 0.72. All right, so now I'm going to use my normal distribution because I just said above that it's normally distributed. So I should be able to use that to find my probability here. So it's a normal curve, so I draw a normal curve. I put a center of 0.7 down because we said up here in part A that the center was 0.7. Then I put 0.72 over here just a little bit to the right, and I shade to the right. All right, then to find that area, you're going to say normal CDF 0.72, 1E99, 0.7, and then you have a choice. You can actually use either that big square root, or you can use the value of 0.052915. Again, you must keep at least 6 decimal places to make this work. So let me grab my calculator. So I'm going to get a normal CDF, number 2, and it was 0.72. 1, remember the E is above your comma button because you're standing in for forever. 0.7, and then here you have a choice. You can do second square root, 0.7 times 0.3 divided by 75. That'll work. There you go, 0.3527. Or, let me go back, do the same thing, but instead of doing this, let me type in 0.05, oh, I gotta remember what it was, 2915. Paste. There you go. And you can see you lose some accuracy at, the 6 decimal place or so, but that's all right. Let me just remind you that if you did it with 0.053, let's just say, let's say you rounded that much, you can see that the answer is not correct. See how you're off in the thousandths place? That's not any good to you. So you want one of the top two. Either use the big square root or use 6 decimal places, but you need a lot of accuracy to make the answer correct. So 0.3527. Oop, hold on, you don't need to see all that. There it is, 0.3527. There we have it. Okay, so now let's look here. We want the probability of obtaining x equals 48 or fewer. All right, x equals 48 or fewer. Again, let me show you where that comes from. So if you say 48 or fewer, that means that p hat is 0.64, but let me prove it to you. Okay, so fewer would be less than. Okay. All right, now where do I get the 64? So 48 out of 75, which is my sample size, would be 0.64. So I turn that 48 or fewer into a proportion, and I want to be less than that, and you can see I've already drawn it right here. So this time I'm going from -1e99 all the way up to 0.64. The mean is 0.7, and again you have an option of either typing in 0.7 times 1 minus 0.7 over 75 or 0.052915. Again, keep 6 decimal places there. All right, so let me go grab the calculator. I'm going to clear all this out just because it's getting kind of confusing here. So number 2, normal CDF, from -1e9. Don't forget to use the negative symbol down here at the bottom. 1 second, comma, 99, then 0.64. 0.7 is correct, but I don't want to use this 0.05. I want square root 0.7 parentheses 1 minus 0.7, close your parentheses, divided by 75. That's one way to type it. Or you could use the 6 decimal places for your sigma p hat, and you get 0.1284. And there you have it. So let's do a double check our answers and everything with the sheets right here. So we have 0.0529, there's your standard deviation of the sampling distribution of p hat, i.e. your standard error. And then we have 0.3527 for letter B, and they came up with 0.1284 for letter C, which I believe matches our 2 answers. So there you have it. That's how to do that problem with your calculator. All right, I hope that helps, and I'll see you back here for more video tutorials.